Thank you. It's great to be here. I'll decided to spend the first minute just on a general remark. I'm doing mainly teaching in biomedicine, and I found this meeting here really super inspiring. You know, having patients and then a data scientist and people from companies talking in one meeting on the same topic. I think this is really awesome. So I'll take a lot of that back to the, and I would love that some of the students also could really experience such a meeting. So I find this really an awesome effort. So I would like to, I'm a systems biologist, so I would like to give you a bit of one vignette of a computational tool which we are developing since long and which I think has some great potential in drug repurposing. And we are specifically looking into metabolism. And I'm in the Cancer Institute, so I do a lot of cancer work. And we know that there are a lot of changes of metabolism in the various cancers, and they're very different, and they can also be very different from patient to patient. So that's the basically the setting, and we developed a computational tool who would help us to screen potential drugs for repurposing based on, you know, for example, taking a biopsy from a cancer and then generating some sort of omics type. So the pipelines we are developing are capable of using very different things, RNA-seq or DNA methylation or proteomics. And we are combining the specific data from the cancer then with a prior knowledge metabolic network, which is based on literature, on 50 years of research or even more on biochemistry. And the tools we are using, they're called FastCore, and there are a lot of families. But basically what the algorithms are doing, they are generating from the specific data with the prior general knowledge network, a specific metabolic network. It's like a mathematical representation of the metabolism of the patient, of the tumor. And it's a very, if you manage to get that, it's a very powerful tool. And one thing we can do is we can probe this metabolic network, which we reconstructed for the cancer with, for example, all the FDA-approved drugs. And we do the drug screening, which was shown in one of the earlier talks. We do that in silico, so on a computer. And we can then test if a certain drug has the potential to work on that specific cancer. And this is one case study, which I will briefly walk you through. This is on colorectal cancer. So we did it on the TCGA data set, and we reconstructed models for the cancer and for the healthy controls. So for tissue, which is close to the cancer, but it's not the cancer. And we built these metabolic models, and we could then find some 100 genes, which are essential, and looked into the drug target databases, and we found some 43 drugs from the drug bank back then. That's already quite some while ago. And from these 43 drugs, we saw that 26 were already approved for some sort of cancer treatment. So we thought, okay, we are going in the right direction with the tool, and set approved. And in this study, then we looked into 3 of these drugs and tested them in vitro on some cancer cells taken from a patient. And what we saw, so the lower panel is the colon cancer from the patient, so primary cell line. And the upper panel is the healthy fibroblasts, so the control cells, so the non-cancer cells. And we saw that the 3 drugs in the 3 columns, they worked on the colon cancer cells, but they did not really have an effect on the growth of the fibroblasts. So this showed us that this tool is really capable of picking up some very specific cancer signal in the metabolism. And that was the starting point. And we are now in the progress of developing this further. There, of course, are many other studies in the meanwhile where we show that the tools are promising, and that's where we think it should be. It could really be helpful also in the context of drug repurposing. In general, computational tools, they can help to do a number of things. So we think we can, with this tool, but also with the other tools which were developed, we can work on specific patient cohorts. So with a specific cancer type, in the long run, it could even be possible to do this for one specific patient. So as I said, taking one sample, building the model and doing the predictions. And in general, also these tools could be working on drug combinations, because if the models are good, you can simulate 2 drugs at the same time. And that's something which is not so easy anymore on the on doing it in the lab, or even you could model metabolic side effects in different tissues. Yeah, with that, I hope I gave you a bit of a flavor of what we are doing in research. Thanks for listening.